So, which of the following is correct about chemical analysis? So, copper sulfate crystal contains water. Explain how volumetric and gravimetric analysis determine the percentage of carbon in a sample of brown coal, which had an initial mass of 247 grams. So why do mining companies So, which of the following is correct about chemical analysis? Chemical analysis involves what is present in a sample? Yes, that's true. Chemical analysis is all about finding out what's inside a particular sample. B, chemical analysis involves how much of a particular chemical is in a sample. Yes, that's a sub-branch of chemical analysis. We can actually work out how much of a type of chemical will be in a sample, so that's also part of chemical analysis. Chemical analysis involves only quantitative analysis. That's not true, because it involves qualitative analysis as well. Hold on to this one and see if the last one is more correct. Quantitative analysis includes gravimetric and volumetric analyses. That's also true. So C is the incorrect one, and it's our answer. Okay. So copper sulfate crystal contains water. When you have a crystal of copper sulfate, there's actually water inside that crystal bonded with the copper sulfate. And when the crystal is heated, water is removed, okay? So when we heat the crystal, we actually emit water. So within the crystal of copper sulfate, that blue crystal, there's water. And when you heat that crystal, it emits water, which gives you just copper sulfate. 5.2 grams of copper sulfate is heated to completely remove the water, and the remaining mass was 3.3 grams of white crystal. So the crystal is actually white when there's no water in it. What is the percentage composition of water in hydrated copper sulfate? How do we work out the percentage composition? First, we need to know what the mass of the water is. So the mass of the blue crystal is equal to the mass of the CuSO4, which is the copper sulfate, plus the mass of the water. If we want the mass of the water, all we have to do is subtract these two. Okay, so we know that this is 3.3, and we know that this one is 5.2. So the mass of the water is 1.9. So we now know the mass of the water. Now all we have to do to work out the percentage mass is divide this mass by the total mass of the crystal. Percentage mass and times 100. mH2O over m crystal times 100, and that gives us our percentage mass. And if we do the calculation, what we'll find is the answer is 37%. The percentage mass of the water is 37%. So 37% of this crystal, copper sulfate, is water. Explain how volumetric and gravimetric analysis differ. Well, volumetric and gravimetric analysis are both quantitative. So that's not a difference, it's just something that we should understand. They're both quantitative measures of something. Volumetric measurements are by volume. So we actually are measuring a volume of a particular thing. Usually it's a volume of a solution. Whereas gravimetric measurements are done by mass. So we're actually looking for the mass of something. Usually we find it by weighing something. There's a little bit of a confusion with physics about that. Basically, we're looking for the mass of a particular substance, whereas in volumetric, we're looking for the volume of a particular substance. So there's two measurements that we can take. They're related, but they're not the same. So that's how they differ. Determine the percentage of carbon in a sample of brown coal, which had an initial mass of 247 grams, and after intense heating to remove all the water and other impurities, finally had a mass of 203.4 grams, and that's we assume is carbon. For those who are not aware of the energy industry in Australia, we are mostly or predominantly coal powered in Australia. All of our electricity comes from coal. And in Victoria, where there's a big supply of brown coal, we use a lot of brown coal. Now, brown coal is not as good as black coal because brown coal has a lot of impurities, and particularly it has a lot of water in it. So black coal is what we want, brown coal is bad. Here we've taken some brown coal and it weighed this much, and after we heated it a lot, we got to essentially what is black coal, which is just pure carbon, and it's this much mass. So we're looking for the percentage composition. So the initial mass is 247 from the question, and the mass of carbon left over is this, also from the question. So the percentage mass of carbon is simply just the mass of carbon divided by the initial mass. And if we multiply by 100, you'll get 82.18%. So that's how we calculate the percentage mass. So why do mining companies analyze samples of ores before they choose to mine a particular location? We basically take what's called a core. We dig into the ground and we take out a sample and we analyze it to see if what's inside this particular mineral ore. Why would we want to do that? If the ore does not contain a high enough percentage of the substance actually wanted, then the mine may not be commercially viable. If we realize that our sample has a very low concentration or a low percentage of what we actually want to mine, say iron or copper, then it may not be worthwhile to dig and mine that area because it could cost a lot of money to get very little substance out. So it may not be worthwhile to actually mine this area if we know that the percentage mass of that substance is low. So that's why we look for these kind of little tests before we go and invest a lot of money into big mining operations. So that concludes today's lesson on gravimetric analysis. We looked at what a chemical analysis is and how it breaks down into different forms of analysis. And then we took a focus on what gravimetric analysis is and how we use it to understand what's inside a particular chemical. Okay? So in the future, we'll look at more analysis types and what first-hand investigations you'll actually be able to do in your labs. So I look forward to seeing you at our next lesson.